Hi everybody. So as I said, we're going to talk about vector addition. Now, before I actually get into vector addition, I want to remind you what it means to add and subtract. And this may sound a little silly, but bear with me here. So let's say if we have 5 plus 3 equals 8, right? We all know the answer to that. If I were to subtract 3 from 5, right? Is there another way that I can write this? I could write it as 5 plus negative 3. It's the same thing, right? Because plus multiplied by negative, it will give me a negative. So it's just the same as writing 5 minus 3, and the answer is equal to 2. So same thing when we have a vector addition. So let's say if we're adding vector A and vector B together, the answer to them, let's say we're going to call it C. But if I'm subtracting them from each other, I can actually write it as a vector addition. So I can write it as vector A plus the negative of vector B. Let's call that vector D. Now, I'm going to show you how it would actually look like on a plane. So here I have vector A and vector B. So let's say if I were to add these two together, all I have to do is to take vector B from its tail and connect it to the head of vector B. And what do I mean by that? So this is my vector B. I'm going to take the tail and I'm going to attach it to the head of vector A. Then once I'm done that, I'm going to take another vector from the tail of vector A, which is my initial vector, to the head of vector B, and that will be my vector C. So let's take a look at subtracting them from each other. So now that I have vector A minus vector B, it's the same thing as saying vector A plus the negative of vector B. So what does a negative of vector B look like? So if I were to do the negative of vector B, it would look something exactly like B, but going in the opposite direction. So this would be my negative vector B. Now then all I have to do is to do the same thing as I did in the previous part, which is to take the tail of my vector B and connect it to the head of my vector A. And it will look something like this. Then once I'm done that, I'm going to use the green color again to connect the tail of my vector A to the head of my vector B. And that is what I call my vector D. We can actually use vector addition in physics and, for example, to find displacement. So let's say I have two vectors that represent where and how I have traveled. Vector A is showing me I've traveled 4 meters east 40 degrees north, and B is 2 meters 10 degrees north of west. So first of all, let's draw this on my plane here, and let's take a look at see how they're going to look like. So I have vector A, which is going east, which is in this direction, 40 degrees north. So it's going to look something like this, and this will be 40 degrees because I'm going east first, and then I'm going 40 degrees north, right? So this is A, and for my vector A, it would be 4 meters in units. Now for my vector B, it's going 2 meters 10 degrees north of west. So this is a tricky part. So it's going 10 degrees north of west, meaning that you're west and you're going 10 degrees north of it. So it's going to look something like this, but it would have a smaller unit. So it's only 2 units, 2 meters. And this would be 10 degrees. So here I have two vectors, and what I have to do is to actually add them together. So what did I do before in adding? I took the tail of my vector B and I added it to the head of my vector A. So it will look something like this. So this would be B. And then my resultant vector would be just from the tail of my vector A to the head of my vector B. So this would be my C, so the addition of these two. I'm going to write it here. So C is A plus B. Now, the way I do this, I actually break these two vectors apart into x and y direction. So then I add the x components together and add the y components together. So let's now take a look at A and find out what the components are. What is the x component on my vector A? My x component is going to be right here. And as you know from sine and cosine, is that this component would equal to 4 cosine 40. So I'm going to write it here. And take a look at the actual value. This is a positive value, so this will have a positive sign here. Always make sure you check the sign. Now over here for B, what is the x component of this one? I have 2 cos 10. So I'm just going to write it here. What is the sign of this part? So this sign is on the negative side, so on the west side. So I'm just going to write the sign right here. Now let's take a look at the y component of vector A. So this one would be 4 sine of 40. So I'm just going to write it here. And for vector B, I'm going to write 2 sine of 10. And they're both positive values, so they're just going to be added together. So once I put these numbers into my calculator, so I put in cosine of 40 degrees multiplied by 4, I will get 3.06. And then I have plus a negative, so the result would be a negative. And then I put in cosine of 10 degrees multiplied by 2, which will give me 1.969. Do we agree? So that will equal to 1.09 roughly. Now for the second part, we'll do the same. So sine 40 times 4, it would give me 4.57115. Plus sine of 10 degrees times 2, which would be 0.347. So once we add them together, I will get 4.92. So this would be the x component of my C. So this would be Cx, and this would be my y component of vector C. Now, if I were to write it better here, I will have 1.04. and 4.92. So these are just the components of my vectors. And how is my vector C going to look like? So vector C is right over here. I know what the x component is, and this is the y component. So in order to get the magnitude of a vector C, as you know, if we have the x and the y, we can use a Pythagorean theory, and I can show you. So this is vector C, this is Cx, and this is Cy, and this forms a 90-degree angle. So if this is my theta and this is 90 degrees, what is actually the magnitude of C? So if you have C of x and C of y, it's just like having, for example, a triangle here. This would be 3, this would be 4. So in order to find this side, what do you have to do? You use the Pythagorean theory. So the question mark is equal to the square root of 3 to the power of 2 plus 4 to the power of 2, which equals to 5. And then you take the square root of it, right? Now, same thing for here. So we're going to use the same method to find my C. So my vector C is basically the square root of 1.04 to the power of 2, which is here, plus 4.92 to the power of 2, which is right here. And then we take the square root of it, and this actually is equal to 25.379. And then once you take the square root of it, it's roughly equal to 5. So the magnitude of my vector C is 5 meters. Don't forget the unit. Now, in order to get the theta here and the direction, because a vector needs a magnitude and a direction, right? So this is just the magnitude. So in order to find the angle, I'm going to use the same triangle to calculate that. So I have my C here, which is equal to 5 meters. This, which is equal to 1.09, and my y, which is 4.92, and this is theta. So I have in a triangle, I have the opposite to my angle, and I also have the adjacent to my angle. So what can I use? Can I use sine, cosine or tangent to include opposite and adjacent in the same equation. So sine theta is the opposite side over hypotenuse. Cosine is the adjacent over hypotenuse. But tangent is actually the opposite over adjacent. So therefore, if I use tangent, I can actually get an answer for my theta without having to do anything else, without having to actually use this. Why don't I want to use this? Is because I actually calculated in the first part. I don't want to use this just in case on an exam, if I made a mistake in calculating this, I don't want to get my theta wrong as well. So I actually want to get some mark. I'm going to use tan of theta equals the opposite, which is 4.92 over 1.09. That is equal to 4.51 in my calculator. Therefore, theta is actually arctangent, so the inverse tangent of 4.51, which is equal to 77.5 degrees. Which, if you actually take a look in my picture previously, it makes sense, right? The numbers look good. So this looks like a 77 degrees, and these, the angles and everything just makes sense in this plane. So if you like the video, like and subscribe, and click on the next video for more examples on vector addition and subtraction. Thank you.